Hello students, welcome to the online session for the subject of industrial safety. Here the industrial safety subject is for the students of structural engineering and mechanical engineering. So we have started this subject for the industrial safety of our SEM 3 students, and we have already completed module number 1 and module number 2, and now we are entering into the module number 3. We have started module number 3. We have completed the wear, lubrications, types of wears, many topics related to wear, many topics related to lubrications we have already completed. Now we are moving towards the corrosion. So let's start the corrosion. So basically the content that we are going to discuss is principle of corrosion, introduction, electrochemical cell, anode reaction, cathode reaction, thermodynamics of corrosion, standard electrode potential and polarization, power BX, diagram of ion, kinematic of corrosion, mixed potential theory, passivation. These are all the things that we are going to discuss in the online session. So let's start with the introduction. That what is metallic corrosion? It is nothing but it is an electrochemical nature of the metals. Okay? An electrochemical reaction is nothing but the transfer of charge in addition to the transfer of mass. So when the transfer of mass takes place, then some material from the object will be removed. And once such object is material from the object is removed, then we can say that the corrosion has occurred. Because in corrosion, the thickness of the material is getting reduced. So yes, it is the transfer of ions, transfer of material. An electrochemical reaction may be split into two or more partial oxidation and reduction reaction. So basically, when an electrochemical reaction is formed and if the oxidation is taking place, then we can say that the metallic corrosion has occurred, and ultimately the transfer of ion will take place, the transfer of the metal will take place, material will also take place. Now next is electrochemical cell. What is electrochemical cell? We are all know that what is the electrochemical cell. Let's first see what are its components. So first, basically, the first is anode, that is the metal that is corroding, and second is the cathode, which is an another electronic conductor whose surface mainly provides the site of the environment to the react. And we have the electrolyte in which both of them are being dipped. And in electrolyte, the transfer of the ion will take place from cathode to anode. The electrochemical reaction between the anode and the cathode to allow electrons to flow through them. So basically, in electrolyte, the electrons will flow. We have the anode, we have the cathode. Negative ions will move from anode to cathode, and positive ions will move from cathode to anode. The whole transfer will take place in the electrochemical cell. Now see what is anode reaction. So generally the anode metal corrodes, and we are getting the solution as M is equal to M2 Mn plus Ne minus. If the steel is corroding, then it is Fe gives the Fe2 plus 2 electrons. If the aluminum is corroding, then it will give Al3 plus 3 electrons. Generally, this is termed as the oxidation reaction, means where the corrosion is taking place. Next is cathodic reaction. Basically, cathodic reaction consumes the electrons, okay, that were generated by the anodic reaction. In nature, the neutral and basic environment containing oxygen, the cathodic reaction, this cathodic reaction will take place. That is O2 plus 2H2O plus 4 electrons will give the 4OH minus. Other cathodic reactions are hydrogen ion or hydrogen ion in reduction by hydrogen evolution. That is 2H plus 2 electrons will give H2. Oxygen reduction will also take place, such as H2O2 plus 4H plus 4 electrons gives 2H2O. Metal ion reduction will give Mn plus E electron will give M plus N minus 1. Metal deposition will give N plus Ne gives M. So these are some of the cathodic reactions. Other electrolyte reactions, in for example like HCl hydrochloric acid, the reaction will be dissolution of zinc metal will be Zn plus 2 HCl gives ZnCl2 plus H2. So where Zn plus 2H plus 2Cl minus gives Zn2 plus 2Cl minus plus H2. The net reaction will be Zn plus 2H plus will give Zn2 plus H2. Equation number 3 is summarized in below. That is Zn gives Zn2 plus 2 electron, 2H plus 2 electrons will be give the H2. Question 4 is the oxidation reaction, and the equation 5 will be the reduction. So here this is how the corrosion is taking place on the zinc in HCl. So we can say that we have zinc metal from which some portion of it will move out and it will be moving towards the H ion. So this is how the corrosion is taking place. Some particles has been moved away from that metal. Thermodynamics of the corrosion. So particularly electrode reaction are mainly involving the corrosion that are associated with the decrease in the free energy. And yes, this is what is means basic thermodynamics reaction. The decrease in the reaction energy is taking place. We have the equation of the free energy, that is changing free energy, how it is related to the electrode potential. That is delta G is equal to minus NFE, where delta G is the free energy change, N is the number of electrons, and E is the electrode. The single electrode potential is a measure of the tendency for the reduction to take place. Negative potential indicates the spontaneous reactions. Standard electrode potential and polarization. So now we will discuss that what is standard potential and polarization. So standard electrode potential is developed when the resultant has having a unit activity. Means when the resultant is having the unit activity, the standard electrode potential is been formed. And also we have another condition that the temperature should be 25 degrees Celsius. Okay. So this is a condition in which the standard electrode potential is taking place. Generally, when the reaction is taking place, they are not equal. But at oxidation or reduction, and the potential shift away from its equilibrium well. So this is what the polarization is taking place. So we all know that reaction will never be equal, but there are some net oxidation and reaction that are taking place, and because of this, the equilibrium is being they will shift the equilibrium away from its equilibrium, and this is what the polarization is taking place. Powerback's diagram of ion. So this is how the Powerback's diagram of ion is being shown. Powerback's diagram is the potential pH plot showing the stability of various metals. So this is simple ion. There the top line is the possessivity. Second is the active corrosion. Third is the immunity. Kinematic of the corrosion and potential theory. So let's discuss it. The mixed potential theory by Wagner and Trout consists of the two hypotheses. The first hypothesis is any chemical reaction can split into two or more partial oxidation and reduction reaction, and there is no net accumulation of the electrons in the electrochemical reactions. So this is what the two assumptions of the Wagner and the Trout. Means the hypothesis were this. So kinetic corrosion rate and potential, the anodic and the cathodic reactions both are occur simultaneously in different parts on the different parts of the matter. So basically the electrode potential of the two reaction coverage, the potential, corrosion potential or polarization. The current density at this potential will give the rate of the corrosion. Means basically the current density of that will give the rate of the corrosion. Means how much the corrosion has been moved away and it is deposited at the other places. And so means how much is the reduction in the matter passivation. So we all know that metals like chromium, titanium, aluminum, and nickel and iron has a reduction in their corrosion rate because of their formation of the oxide film. So this is how the passivation of the corrosion will take place, and as a result, they have excellent resistance to the corrosion. Yes, this is how the passivation is taking place. Now, a figure is also shown over here. That is the how the passivation is taking place. Thank you for attending my session. This is Professor Akasar Suthar. Thanks for attending my session. See you in my next session. So, students, thank you for attending the session. Here, this is ending of the session. At the end of the session, the uh, this PDF is attached to the session. The PDF will be in the form of a link. On clicking on this link, you will be getting a PDF, and there you will be getting the questions regarding our session or this session. So you find the link which will be given in the description of this video, and by doing so, you can have the you can get to know how what kind of question can be asked in the exam. uh, what are the type of question, what are the types of the MCQs that can come, what are the short questions that can come, what are the brief questions that can come. So by this, to have an exercise of such type of question, I have attached the MCQ. Sorry, this it's as an kind of assignment sheet or a kind of a quiz is being added in the link. So do find the link, and to find the questions, try to solve it, and by solving it, your skill regarding the questions of intercessivity will get increased, and you can come to know that what kind of questions can be asked in the exam. Yes, do find the link that is given below it, and yes, you can ask the questions through mail or any kind of. You can send me your questions. You can send me your doubts. I will try to solve it. So do find it, and thanks for attending this session. This online session is very much useful for distance education. So it will be very much helpful for me. Sorry, but it has got many help to the other students also. So yes, these sessions are very much helpful. Attend this session, grab knowledge, and thank you for attending my session. This is Professor Akash Sutar. Jai Hind.